Have you ever wondered how bolts, fasteners, and metal studs are permanently attached to steel structures without drilling holes? The answer is stud welding, one of the fastest and most efficient welding methods used in construction, shipbuilding, automotive manufacturing, and heavy industry. In this video, you'll discover what stud welding is, how it works, the different types of stud welding, its applications, advantages, disadvantages, and why it's become the preferred fastening method for many industries. Stay until the end, because you'll also learn why stud welding can create a full-strength weld in just a fraction of a second. Imagine attaching a metal bolt to a steel plate in less than a second without drilling, tapping threads, or using nuts and bolts. Sounds impossible, right? Yet this exact process happens thousands of times every day in factories, shipyards, bridges, skyscrapers, and even modern automobiles. Look closely at large steel structures, and you'll find hundreds or even thousands of studs permanently welded onto metal surfaces. These tiny components play a huge role in holding insulation panels, electrical systems, machinery, and structural parts securely in place. The process behind this incredible feat is called stud welding. Unlike traditional welding methods that require joining two large pieces of metal, stud welding focuses on attaching a fastener directly to a metal surface, quickly, efficiently, and with remarkable strength. But how does it actually work? What makes it so fast? And why do industries rely on it instead of conventional fastening methods? Let's find out. What is stud welding? Stud welding is a welding process used to permanently attach a metal stud, bolt, pin, or specially designed fastener to another metal surface using heat generated by an electric arc. In simple terms, the process creates a strong bond between a metal fastener and a metal workpiece without requiring holes, nuts, or additional hardware. The fasteners used can be threaded studs, unthreaded studs, tapped fasteners, weld pins, specialty weld nuts. One of the most impressive features of stud welding is speed. In many cases, a complete weld can be formed in less than a second. That's significantly faster than drilling holes and installing mechanical fasteners. Stud welding is often compared to flash welding because both use intense heat to fuse materials together. However, stud welding is specifically designed to attach fasteners directly to a metal surface. The result is a permanent, high-strength connection that can withstand heavy loads and demanding conditions.
Why stud welding is so popular? Modern industries demand faster production, stronger joints, and lower labor costs. Stud welding delivers all three. Instead of drilling holes, aligning bolts, tightening nuts, and inspecting connections, a stud welder can create a permanent fastening point almost instantly. This saves time, labor, materials, production costs. It also preserves the integrity of the base metal because no holes are drilled through the material. That's one reason why stud welding has become essential in large-scale manufacturing and construction projects. Applications of stud welding. Stud welding is used across countless industries because it offers strong, reliable fastening solutions. Construction industry. Walk through any modern skyscraper, bridge, or commercial building, and you'll likely find thousands of welded studs hidden beneath the surface. Stud welding is commonly used for structural steel frameworks, bridge construction, building supports, steel decking systems, insulation fastening. The process helps create strong connection points while speeding up construction. Shipbuilding industry. Shipbuilding is one of the oldest and largest users of stud welding technology. Ships require thousands of fastening points for electrical systems, insulation panels, interior structures, mechanical equipment, deck fittings. Stud welding allows these components to be attached quickly while maintaining structural integrity. Without stud welding, ship construction would take significantly longer. Automotive industry. Vehicle manufacturers use stud welding extensively during production. Applications include body panels, interior brackets, electrical mounts, exhaust system components, structural reinforcements. The speed and repeatability of stud welding make it ideal for assembly lines. Aerospace industry. Aircraft manufacturing demands lightweight yet durable fastening methods. Stud welding helps secure panels, brackets, electrical components, structural assemblies, while minimizing weight and maintaining strength.
Electronics industry. Stud welding is commonly used for circuit board assemblies, switches, control panels, electronic housings. Its precision makes it ideal for delicate manufacturing applications. Decorative applications. Stud welding isn't limited to heavy industry. It is also used for signs, nameplates, decorative metalwork, jewelry, home furnishings. This versatility makes stud welding valuable in both industrial and artistic environments. Equipment used in stud welding. Before understanding the process, it's important to know the main components involved. 1. Power supply. The power supply provides the electrical energy needed to create the welding arc. Most systems use direct current, DC, because it provides stable arc performance and strong weld quality. 2. Controller. The controller manages critical welding parameters such as arc duration, current level, timing, weld sequence. Modern controllers ensure consistent weld quality. 3. Stud welding gun. The welding gun holds the stud and controls its movement during welding. The gun automatically lifts and plunges the stud during the welding cycle. This ensures precise operation every time. 4. Ground cable. The ground cable completes the electrical circuit between the welding system and the workpiece. Without a proper ground connection, welding cannot occur. Types of stud welding. Not all stud welding processes are the same. There are 3 major types used throughout industry. 1. Arc stud welding. Arc stud welding is the most widely used stud welding method. In this process, an electric arc forms between the stud and the workpiece. The heat generated by the arc melts both surfaces. The stud is then pressed into the molten metal, creating a permanent bond. Advantages: suitable for larger studs, strong welds, deep penetration, excellent structural performance. Common materials: mild steel, stainless steel, aluminum. Arc stud welding is frequently used in construction and heavy fabrication.
Capacitor Discharge Stud Welding. Capacitor discharge, often called CD stud welding, uses stored electrical energy from capacitors. Instead of a longer arc cycle, the stored energy is released almost instantly. The welding cycle is extremely fast. Benefits: minimal heat input, little distortion, no flux required, cleaner weld appearance. This process is ideal for thin sheet metal, light gauge materials, decorative applications. It also reduces oxidation because of its short welding duration. 3. Automated and robotic stud welding. As manufacturing becomes more automated, robotic stud welding continues to grow. Computer-controlled systems can position studs accurately, maintain consistency, increase production speed, reduce human error. These systems are commonly found in automotive factories, shipyards, industrial manufacturing plants. Automation allows thousands of studs to be welded every day with exceptional precision. How does stud welding work? Now let's break down the actual welding process. Although different systems vary slightly, the basic principle remains the same. Step 1. Load the stud. The operator places a stud or fastener into the welding gun. The gun securely holds the stud in position. Step 2. Position the stud. The stud is pressed against the surface of the workpiece. Proper positioning ensures accurate weld placement. Step 3. Trigger the welding cycle. When the trigger is activated, the welding gun lifts the stud slightly away from the workpiece. This creates a small gap. Step 4. Generate the electric arc. Current flows through the gap and creates an electric arc. This arc generates intense heat. The heat melts the end of the stud, a small portion of the base metal. Both surfaces become molten. Step 5. Create the weld pool. The molten material forms a weld pool. In arc stud welding, a ceramic ferrule may be used to contain the molten metal and concentrate the heat. This helps create a stronger weld.
Step 6. Plunge the stud. The welding gun quickly pushes the stud into the molten pool. The molten materials fuse together. Step 7. Solidification. The molten metal cools rapidly. As it solidifies, a permanent metallurgical bond is formed. The result is an exceptionally strong weld, capable of handling heavy loads. The entire process often takes less than 1 second. That's why stud welding is one of the fastest fastening methods available today. Materials suitable for stud welding. One major advantage of stud welding is its ability to join different metals. Common materials include steel. The most popular stud welding material because of its strength, affordability, and versatility. Stainless steel. Ideal for environments requiring corrosion resistance. Common in food processing, marine, and chemical industries. Aluminum. Lightweight and corrosion resistant. Frequently used in automotive and aerospace applications. Copper. Offers excellent electrical conductivity and corrosion resistance. Used in electrical and industrial applications. Brass. Provides attractive appearance and good corrosion resistance. Common in decorative and specialty applications. Advantages of stud welding. There are many reasons industries choose stud welding over traditional fastening methods. Extremely fast. Most welds are completed in less than a second. Strong joints. The resulting bond is often as strong as the base material itself. No drilling required. Stud welding eliminates the need for holes, preserving material strength. Single-sided access. The operator only needs access to one side of the workpiece. Cost-effective. Reduced labor and material costs improve overall productivity. Clean appearance. The finished product looks neat and professional. Versatile. Works across many industries and applications. Suitable for automation. Robotic systems can perform stud welding with incredible accuracy and speed. Disadvantages of stud welding. Despite its advantages, stud welding does have some limitations. Specialized equipment required. Stud welding machines can be expensive compared to basic welding equipment. Requires proper surface preparation. Dirty or contaminated surfaces may reduce weld quality. Limited to specific fasteners. Only specially designed weld studs and fasteners can be used effectively. Training is necessary. Operators must understand welding parameters and machine settings.
Material limitations. Some material combinations may require special procedures. Why stud welding matters in modern manufacturing. Many people never notice stud welds because they're often hidden behind panels, insulation, or structural components. Yet these small welds help support some of the world's most important structures, from massive bridges and skyscrapers to ships crossing oceans and vehicles traveling highways. Stud welding provides fast, reliable fastening solutions that save manufacturers time and money. Without it, modern manufacturing would be significantly slower and more expensive. Conclusion: stud welding may not be as famous as MIG, TIG, or stick welding, but it plays a critical role in modern industry. By using an electric arc to fuse a fastener directly to a metal surface, stud welding creates strong, permanent joints in a fraction of a second. Whether it's used in shipbuilding, construction, automotive manufacturing, aerospace engineering, or electronics, the process continues to prove its value through speed, efficiency, and reliability. The next time you see a bridge, a steel building, a ship, or even a vehicle, remember that countless stud welds may be working behind the scenes to hold everything together safely and securely. And that's exactly why stud welding remains one of the most important fastening technologies in the modern world.